Hello programmers! Today we're going to talk about the exciting topic of function templates. But first let me look at these two functions. These two functions have a lot in common. One function takes two integers and adds them together and prints them to the screen. And another function takes two strings, and when you have strings, the addition operator concatenates those two strings and it'll print that to standard output. So in main, I'm combining or calling the function combine on 5 and 4, and it'll add those two numbers together and print to the screen the number 9. And then next I've got two other strings, happy and Halloween, and if I call the combine function, then I get happy Halloween. Happy Easter might be more relevant for this time of year, but we've concatenated two strings. So what's the problem? Everything seems to be working fine. Well, with object-oriented programming, you want code reuse, and you want to be able to write something once and be able to use it more than one time. So what we'd like to do today is, instead of having two functions with the same name and an identical function body, we want to see if we can write one function that can be used by both this line that's passing in integers and this line that's passing in strings. Well, it can be done. First I'm going to just delete one of these combined functions because we want one function that does everything. And it's not always going to have strings. We don't know ahead of time what kind of data type we're going to pass in, but as long as whatever we pass in can handle the addition operator and the insertion operator, we don't care. So I can't just put a bunch of question marks. I need to have a better way for C++ to be able to figure out the data type. And I'm going to add a special line here, template, and then class, and then what I have here is like a variable. The convention is to use a single uppercase letter as a placeholder for that generic data type that you want to pass into the function. So instead of question marks, I would say data type T. I'm going to have data type T, and I'm going to have two inputs, X and Y, both of data type T. So this line right here kind of sets up that there's going to be a generic data type you can use in this function, and T is the placeholder for that data type. So it doesn't matter whether we're passing in ints or whether we're passing in strings. This function template can handle either one. At compile time, it will find out that the arguments you're passing in the first call are ints, so the compiler will create a version of this function where in place of the capital T it puts int. And in the second call for combine, the compiler will see that these are both strings, so it's going to create a version of combine where capital T is replaced with strings. So once you compile the program, the executable is going to work as if we had two functions, but it's quite efficient the way we've written the function as one function inside of our .cpp file. So let's go ahead and run this and verify that it does still work, and we can still add two integers or we can add two strings. And hey, we could even add two floating point numbers, whatever we want, as long as it can handle the addition operator and the insertion operator. Okay, so this right here is a function template. Function templates can also be overloaded. So we know overloading is when you have the same function name and a different number of arguments or different types of input arguments. So I could add a third generic data input to this function, and we could say define what does that mean to combine three whatever, it's three values. And then we could now call our function either with, and actually I'm going to add some floating point numbers just to show that it'll work with that as well. And we'll see that we've now overloaded the combine function, which was a function template, and we have two different versions, one that works with two inputs and another that works with three inputs. And it would concatenate three strings together if we called it with three strings. Okay, so we've overloaded our function template. Every time you have a different version of that combine function with different arguments or different number of arguments or types of arguments, you're going to have to repeat this line template class T. So repeat it once for every function that uses generic programming. We can also create objects. So if we had a class, like a Pokemon class or a pizza class or something, we could still use these combine functions as long as that class knows how to deal if there's an overloaded addition operator and an overloaded insertion operator. Then it would be fine.